Hi everyone, just making a quick video on a hardware project I've been working on. I do a lot of open source stuff and there's been some software products I've put out, but this is the first kind of hardware based project that I'm making available. It's essentially a single channel biopotential sensor and amplifier. So it can do EEG, EMG, EOG and ECG, all of them. So it has all of the analog front end, so you can connect sensors by this 3.5 millimeter jack. Unlike a lot of previous similar products, this one actually has an ADC, analog to digital converter, on the board, so it takes the signal coming from the sensors and it digitizes those. This is a 24-bit ADC. There's no soldering required. You can use these stemmer QT, or they call them quick connectors. So you can connect these to a lot of common, anything that's kind of like Arduino based, any MCU that has I2C basically. And I've got a couple of example projects based on a couple of feather boards that I've used. So one's the Adalogger, which I've used on previous projects a few times, and then also an STM32 project. But yeah, it just gives you two different examples of how to use this. So there's more details on how to get the Arduino firmware that I made for this on my GitHub page in the campaign story. And any Arduino device that has the I2C peripheral will work with this, so it gives you a lot of options. And there's a few drivers for the ADS 1219 that you can use. So yeah, there's a lot of flexibility in how to use this. So this will come with the Breakout board, the sensor cable, a bunch of electrodes and a stemmer connector to connect to your MCU project. So I should have everything you need to get up and started. I mean, the reason why I've made this is because I don't think there's many options for an affordable and easy to use analog front end for EEG. So the other thing this has got on here is an accelerometer, so you can track motion as well. And there's a lot of use cases when you're looking at biopotential signals where you look at motion as well. So sleep tracking that I've been talking about, that's a good example. So looking at movement data, head movement data, for example, along with sleep staging is pretty useful. And that's also interfaced by I2C, so it just goes along the same cable. So it has all the standard kind of input protection circuitry and device protection, so user safety is kind of covered. Yeah, you'll be able to run this off of mains or battery with no issues, just depending on how your MCU is powered. So it's been through a few iterations. Like I say, there's various different combinations I tried with this, different amps, different kind of board layouts and separating things out. But yeah, I feel like this is in a good place now, ready to kind of get out. If anyone's got any questions, just feel free to write some comments here or email me, and I'll be happy to answer them.